This is a video about springs. Now, springs are something that we cover back in Physics 1 when we were talking about forces, and then we talk about it again when we do energy, because the spring force is given by Hooke's law. And the spring force says that my force is equal to negative k times x. A quick reminder, k was our spring constant, and it had units of newtons per meter. In case you don't quite remember, a spring constant is just a measure of how strong or how springy a spring is. So a big spring constant is something you might see in the suspension of your car. A small spring constant is what you might see in the spring in the back of a pen. A spring has a natural length, so if I've got a spring like this, my spring has a natural length, and when I attach this to maybe a wall on this side and maybe I put a block over here, then that means this right here would be the equilibrium position for the spring. When I compress that spring, I am getting some kind of an X value. So if I compress this spring to here instead, let's see, if I compress my spring to here with, again, then I have moved it inward. That would be my X. Because X points to the left and there's a minus sign here, my force points to the right. The same thing happens in the other direction. If I stretch it out, my X points to the right, my force points to the left, and that makes this a restoring force. Hooke's law is applied not just to springs, but to anything where the force is a restoring force and it's directly proportional to the displacement. The other piece that I really need from springs from before is the potential energy stored in a spring. If you are in Physics 2 and you took Physics 1 elsewhere or with a different instructor, it might drive you crazy that I use PE for potential energy. I know sometimes you'll see a capital T, sometimes you'll see a capital V or a capital U. Those work great. It's nice to have one single letter for a variable name. I use PE because you know exactly what it is that you're talking about with potential energy. That's just what I do. So I've got a force and I've got a potential energy. Potential energy is a measure of energy, so it gets measured in joules, where 1 joule is 1 Newton meter. Those are really the pieces that we need for now, and that's it. We'll keep moving.